Hello, Kirtana. I'm audible. Please let me know first.
Yes, sir.
Audible, right? Okay, let's go to the topic. Okay, Okay, Kirtana. So we were at the structural model of conductor. Okay. So yeah, there we had a discussion. Okay, so Kirtana, what happens is we had discussed right about this current. Like we have something called drift velocity and something like that. So on the basis of model, we have to first figure out the expression for the drift speed, right? Just a second. I'll just Kirtana, can you hear me?
Yes, sir.
Okay, so Kirtana, let's go to the topic. Drift and velocity of free electrons. Okay? Free electrons. Okay, so I'll just try to make a situation out of it. So let's say this is a conductor, and this is a this is a complete conductor. Okay, and we have just insured our battery with this. So this is a battery. Basically, you can say this is positive terminal, negative terminal. Okay, and maybe I can just make a switch over to S. Okay. So look, now what happens in general is this is a conductor given to you. Okay, a conductor has a lot of electrons. Okay, so whenever you apply a potential around it, we can assume that because this is a negative potential, you know that if I write this is V, this is nothing but the potential difference. If I say this is point A, this is V, so I can simply say VA minus 3B is equals to 0. A, okay, V. So if I assume that VB is 0, basically this whole term is 0, if I just connect it, so this point you can say it is 0, this point you can say that is V. Is that clear, Kirtana, for now?
Mhm.
Okay. So basically, you can say that as a negative, due to the negative terminal, you are assuming it to be zero, so the other side that will come out as okay. This is one thing. Now I can say what is the total potential difference across this conductor Kirtana?
V, sir.
V, right? And you know, Kirtana, if there is a potential difference across this conductor, you can simply say that there will be an electric field, right? What is the direction of electric field? This one, right? Because if you can assume now this is a potential V, means this is a higher potential, mean to say this is a positive place, right? And here it is negative. So you can simply say that there is an electric field in this section. Can I say this, Kirtana?
Yes, sir.
Okay. Now, Kirtana, you know, like if I don't have any electric field, so what happens? Let's say I don't have any potential and I have not connected it to the battery right now. My switch will open. Okay. So in this condition, Kirtana, what will happen? There's a lot of electron inside. Okay, they will be moving in a very random direction. In absence of electron, in absence of electric field, electrons will be moving in random direction, or you can say a kind of Brownian motion, or a kind of Brownian motion. What is kind of Brownian motion created? You can simply say this is an electron moves this way, moves this way, moves this way, like very random direction. You can assume of whatever. Okay, this is kind of motion will be there. Okay, is that clear, Pujira?
Yes, sir.
These are the electrons which are actually moving in the free electrons. Okay. Brownian motion, that's the Brownian motion of gas molecules. Okay. So, Kirtana, what do you think? Is it a motion of electron, Brownian motion?
Yes, sir.
Hello, Kirtana. No, it is not. Look, I am saying they are moving in a random direction. A kind of, okay, this is not a Brownian motion. I'm not saying that electrons move in a Brownian motion. It is just a kind of Brownian motion which we observe in case of gas molecules. Okay, this is what I'm saying. So, if I'm having an electron, it will be moving in this direction. It might be moving in this direction. If it is here, it might like anywhere. These are the things. Okay? But the
Yes,
moment I apply an electric field, situation is going to be changed a bit. Okay. Okay. So Keith, now just assume out of the lot of electrons which were moving in the random manner, I'm just picking up this electron. Keith, now what is the force on this electron due to this electric field? Of electron. Okay, I'm saying this is y, this is x. Keith, just let me know what will be the direction of force on this electron. Okay. Keith, now please let me know. Keith, you don't know how to calculate direction of force on the electron. Keith, you know or not? Just let me know
no,
first. Okay, you don't know.
no, sir.
Why you don't know? Please don't say, again, don't say that you spent a lot of time in your college. Again, don't say the same thing. I have asked you multiple times, like the same question. Why didn't you told me earlier that you don't know how to calculate the direction of electron? You know this direction of electron thing. I taught in the maybe the first or second section where I taught you the Coulomb's law part. We had a two discussion. One is a normal way, a magnitude. After that, we had a vector, which consists of directions and all. Still, you are not able to calculate direction of force. If I wouldn't have asked specifically, you would not even get told me this same. Okay, what is the formula for force between two charges?
Q1, Q2 divided by us.
So why it is difficult for you to calculate the force here in this particular case? What's the case? Please let me know. Be clear, okay? So why it is difficult for you to calculate here in this particular case? What's the difference here and there? When I ask, give me the direction of a force due to an electron in field, no response. I'm at the electric field chapter right now. So how you are every time when I say I'm making these figures and I say okay this is the direction of electric field. Why you say yes? When I ask you just type yes sir, yes sir, yes sir. Does that even make sense? When you're writing a lot of yes sirs and you don't know how to the things are coming out of there. Here's the which grade you are in right now.
12th, sir.
12th, right? You have to give next year NEET, is it?
Yes, sir.
Okay, fine. I'll remove this 12th grade. Okay, what is the moment of inertia of this ball at a distance r rotating in this circle with some omega speed? This is angular velocity. Okay. What is the moment of inertia of this ball? Axis of rotation. This is in starting an introduction of a very big chapter, okay, which consists of good weightage from your NEET portion also, JEE portion also, whatever exam you are going to give. Okay, yeah, that's not the important part. The distance is given as r. Give me the moment of inertia shear of mass m, okay, with respect to axis of rotation. It's a grade 11 topic, not even 12. Kitna, please be loud, okay? Just don't go with yes sir, no sir, and whatever you have. Just please be clear and let me know if you know the things or not. Okay.
I don't remember, sir.
Yeah, you don't know this topic, right? I just studied rotational motion. Kirtana, okay, which topic you know very well? Okay, that one topic, just let me know first. Like, it doesn't make sense. I'm teaching a chapter third. I'm asking a basic of chapter one, which basically, yeah, that can also be like whatever you know. If you just know F is equal to K over Q2 by R square, the same thing a grade 10 student also knows. So what's the difference between you and that person? Kirtana, which chapter you are good in the whole of the physics, grade 11, 12? Yeah, it's up to you. Like wherever you studied, doesn't matter. Which topic you are good at? Okay, please let me know that first.
I'm not good at any chapter, sir.
What? No. What I can say, Kirtana, and this was. Okay, you have three, except bio, you have chemistry, you have physics. The best chapter you have in these two books. Okay, I have given you the two books, two subjects now. Whichever chapter you see, said, okay, sir, this is best for me. Just please come up with it. Come up with that chapter. Not in the physics, but come up with the chemistry itself.
Organic chemistry, sir.
Organic chemistry, okay. Chetana, what is a Canning-Java reaction?
Sir,
What is a Canning-Java reaction? Okay, Chetana. Chetana, name any four labels. Chetana, what is the this is what is it? Okay, Chetana, what is polar molecule and non-polar molecule? I don't know why I have a shift from physics to chemistry, but I think I can. Yeah. So, what is a polar and non-polar molecule?
polar molecules are like water which
No, I'm not asking for the example which you can try to give me as a water because for the water I have already taken a lot of the times example of the water. What is the real polar molecule? When I say a molecule is a polar, what does that mean? Okay, and if you are asking about the water, why the water is a polar molecule? That also you can tell
has
me.
partial negative and positive charges.
Partial negative and the positive charges. Okay. So how does that make it a polar molecule? That partial term I know. I told you that thing. With respect to chemistry, will you say that it has a partial positive partial molecule? No, I don't think so. Okay. Kirtana, you said you're good at the organic chemistry, right? I can. Okay. Can you don't know, right? Any reaction, Kirtana, in which you are good at, any particular reaction, the whole organic idea.
Preparation of alcohols or phenol.
Preparation of alcohol, right? Okay, so you are done with the preparation of alcohols. Okay, which method I can go with then? We have studied that. Okay, Kirtana, what is Grignard reagent?
Magnesium with X is like
Okay, when you use a Grignard, okay, to make out of to make an alcohol out of that, okay, which kind of alcohols you can prepare from that?
primary, secondary, tertiary. Sir.
Okay, which reaction is there which uh, want to make a tertiary alcohol?
Ketones make tertiary alcohols.
No, no, that's not what I'm asking. Like ketones make tertiary. I'm saying which does not make tertiary.
Formaldehyde aldehydes.
You have marked up organic very good, I think. Okay, no problem. You can actually do that part because you won't be getting a lot of things over there. So, Kirtana, yeah, what's the problem in the physics? Yeah, Kirtana, what's the problem which comes with you in the case of physics? Okay, Kirtana, so what should I do? Like, should I just go, like, I'll just write what's the electric field and should I go in that way or should I teach this from first chapter itself? It's your call what I should do. If you want, we can start from the first chapter. I don't have any problem. I really don't have any problem with it. It's your call. Or I can just complete this chapter and the next and next and so on. If you want all the syllabus to be covered in a very quick manner, so I'll cover this chapter within the next two session and the so on for the others. Your call again. So please be clear with me in this cases. Yeah, Kirtana, please tell me first. Look, silence doesn't make any solution. So be clear. Uh, like it does not. It seems good. Like I'm just calling to sir and saying, sir, please have a conversation with Kirtana and get to the review. Okay, it does not make any sense. Kirtana, you are taking one session so that you can clear your doubts, not your syllabus. Okay, one-on-one sessions are meant for the doubt clearance, not for the session completion. What I have felt in the last many, like whatever the classes I'm taking, I'm just completing the syllabus, not doubt. You never give me any doubt. Whenever I'm saying, Kirtana, are you clear with the things? Yes, sir. Not three or four words, just yes sir, no sir, yes sir, no sir. Whenever I come up with a very random question, just very basic, sort of. Kirtana, what I should do? Just be clear, get me the answer. And, yeah, I'll move on that way. Okay. I'll just, if you say complete the chapter, I'll just go and complete the whole chapter. Kirtana, where are you? Are you there or not? Hello, Kirtana, are you there? Please let me know first. Kirtana, hello, Kirtana, are you there? Can we continue? Kirtana, hello, Kirtana, are you there or not? Please let me know this. What I should do. Kirtana, should I start from the first chapter, basic, your doubts, whatever it is, just let me know and be clear with me, okay, in this case. Are you there even the session? Okay, so I have to start from the very first chapter, right? Okay, so why didn't you just clear your doubt when I was asking for the doubts instead of saying yes sir and yes sir again and again? This is a third chapter, David. This is not sense to start from the first. Okay, all right, Kirtana. Um, this is okay, Kirtana. So can we just do one thing? I'll just go through your syllabus and all. Like if you're not interested a lot at all. Okay, Kirtana. So here we got okay. So when I said an electron is there, okay, an electric field is there, an electron is there. So basically, electron experiences a force. Okay, what is the direction of force? I'll just simply go come up with that thing. Force is nothing but K Q1 Q2 divided by R square. Force can also be written as in a vector form Q times of electric field. Okay? If you just see my charge is nothing but minus. Okay, so you can simply write that as a minus E. Okay, so what this negative indicates that the direction of force is opposite to the direction of electric field. So can I say that, Kirtana, if my direction of force is in this, like electric field is in this direction, so can I say that force is in this direction? Kirtana, I'm just going with the things, okay? I have explained the force part also. Okay, so yeah, that's the thing. Force we have, okay? Now, Kirtana, what happens is when you apply an electric field, this charges got some force, but there's a lot of charges. So what will happen is, let's say this is an electron. A previous electron have got the force. It started moving to strike the electron. So you might have studied about the collision head-on or something. Let's say an electron striking with this. It is moving with this way. This will also with this way. So it will just because of the collision, it will change its direction. Maybe this way reaches here. But again, due to the electric field, it will go in this direction. Simple. So this is the final thing happens, and everyone is losing velocity again and again and again. So what you can simply say that they have got an force. Okay, they have got an. You can simply say that. What's the velocity? I can use v is equals to u plus at. Okay. So what will happen is I have to calculate the final velocity because it started from zero. So what is the final velocity they will reach? Okay. This is what I have to calculate. But I can simply say that assume initially zero. What is the A? A is you can simply say the force is this much. So that is mass into acceleration. The acceleration will come out as divided by n. Okay. This is zero times of t. Okay. So velocity you have got Kirtana E capital E divided by n. And what is the t? If I ask you what is the t, so t is basically a small time between collision can be referred as therefore t is nothing but tau, time between two successive collisions. So so finally you can say your velocity and Vd. This velocity is nothing but Vd. You can call it as minus e tau divided by for every material this tau is a limited value. So you can simply say that the magnitude of Vd comes out as electric field tau divided by. Kirtana, please come up with the confirmation if you are done with it, like if you're clear with the things or not. Doubts are there, you can again come up with the same.
No, sir.
If, like, if you have doubt, like if you are clear with this calculation of this, what is it? Drift velocity. So it's fine, I think. For all right, Kirtana. Okay. So look, Kirtana, we have got something called velocity, right? Now, Kirtana, you have got this VD. You can call it as an average velocity, or speed with which electron moves in conductor in electric field. Alright, so this is one thing. Now, Kirtana, if I just give you a conductor, and if I ask you what is the current, you will simply say sir, the total number of charges divided by time. Okay. So let's do Kirtana. What I can do is simply I will try to calculate what is the total number of this charges have been produced. So can I say that that will be nothing but the number density that I can write it as and the capital is basically this is the number density total charge divided by the volume. That is the thing. So you can simply say that n into v. This is the volume, okay, divided by 2. Okay, this is capital N. Okay, what is the volume? You can say that the volume is nothing but okay. This many times of electron. Basically, this is a number. Okay, this is a charge. So what is the total charge basically? So I just need to. It should be number of electrons. Okay, these are many electrons, and you can simply say, sir, these many electrons we have. I'll just move it for a while and divided by v. So this will come out as uh, number density velocity volume multiply electron divided by 2. Number density number of electron volume. All right, these things I have got. Anything I can get? I don't think. Okay, let's open this one. If you just open it, you will be getting n times of a times of l. Basically, area into length gives you volume divided by 2. Can you see it? Length divided by area time. That will give you the velocity. So you can simply say that this a and velocity. What is the velocity? That is vd. So this is the formula pattern you have got. VD. So I is equals to, you can say A and this is number density, electron, and V of area of conductor. Area of cross section, don't say conductor. Section. Number density of conductor, electron, and drift velocity. Okay. That is the thing for now. Okay, so we have got another formula for I. So you can see we have already one formula, that is Q by D. If this is equal to A and E V D. A and E V and D. That is the thing. As per the Ohm's law, which we have already studied, what is that? V is equal to I R. So you can simply say that I is equal to V by R, and this I is also equal to A times of N N E V D, right? And what is this? Can I say that this VD is also equals to E capital E divided by N from this formula? And there's a tau also, to just keep the tau. So just put it here. When you put this here, you will be getting A and one E is there, one E is there, E square, electric field, tau by N. This is what you have got. And again, you just have to think of it little bit. What is that? Multiply ups and down by L. What is E into L? That is, well, what is that? Voltage. I is equals to A and E square electric field by this. This and this gives you the volume, voltage. Okay? So you can say that electric field has been removed. It will result in the volume tau divided by L. So can I say that, Kirtana, if I just keep this volume outside, I'll be getting again n square tau divided by L. This is it. Isn't it looking like this whole thing as reverse of R? So you can say that R is equals to L M L divided by N E square tau times of A. Isn't it? If I just compare it with the raw L by E, what you said that raw is nothing but M N E square. This is the formula for all the things we have got till now. Okay, if any doubt is there, I'm just giving you 1 minute. Okay, you can let me know, or else we can end the session by here. Okay, that's all for the today's class. Hello. Yeah, that's all. If you're typing something, you can type and let me know the doubts. All right, Ketan, I can end the session. I hope. So,